I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to see the topic on directional couplers. So, a directional coupler is a 4-port passive device and it is commonly used for coupling a known fraction of microwave power to a port which is called coupled port in the auxiliary line while flowing from input port to output port in the main line. The remaining port is ideally isolated port and match terminated. They can be designed to measure the incident or reflected power and also the standing wave ratio SWR. So in the diagram you can see the directional coupler. There are 4 ports. It is a microwave passive device for coupling the microwave power from one port to another port. So there are 2 waveguides in the diagram. One is primary waveguide and another one is secondary waveguide. So, while seeing the properties of a directional coupler with matched terminations at all its ports, the properties of an ideal directional coupler can be summarized as follows. So, a portion of power traveling from port 1 to port 2 is coupled to port 4 but not to port 3, and a portion of power traveling from port 2 to port 1 is coupled to port 3 but not to port 4. So always power transfer from 1 to 2 and it is coupled to only port 4. And also in the reverse direction, the power is traveling from port 2 to 1 is coupled only to port 3 and it is not to port 4. And there are 3 performance parameters of a directional coupler. They are coupling factor denoted as C, directivity denoted as D, isolation called I. So we'll see the parameters one by one. First one is the coupling factor. So the coupling factor of a directional coupler is defined as the ratio of incident power to forward power PF. So the incident power is denoted as Pi, and the coupling factor is measured in decibels. So the coupling factor formula in decibels is 10 log 10 of P1 by P4, or the incident power to reflected power ratio. So this is known as coupling factor. And the next parameter is directivity. So the directivity of a directional coupler is defined as the ratio of forward power PF to the backward power PB, and it is expressed as in decibels. Directivity dB is equal to 10 log 10 P2 by P3, and isolation is defined as the ratio of incident power PI to back power PB, and it is given as isolation in decibels as 10 log 10 P1 to P3. So in our lab also we have 2-hole directional couplers. So here a 2-hole directional coupler consists of 2 waveguides, and one is named primary waveguide and another one is called secondary waveguide, and they have tiny holes in between them. The 2 holes are at a distance of lambda g by 4. Here lambda g is known as guided wavelength. And in the 2-hole directional couplers, a fraction of wave energy entered into port 1 passes through the holes and it is radiated into the secondary waveguide as the holes act as slot antennas, and the forward waves in the secondary waveguide are in same phase regardless of the hole's phase and are added to port 4. And what happens to the backward waves is it is in the secondary waveguide which is out of phase by 180 degree at the position of first hole, so they are cancelled at port 3. And we know the direction coupler is a 4-port network, so its S matrix is 4 cross 4 matrix. So the S matrix consists of S11, 12, 13, 14 in the first row, and similarly it is still S44. And due to symmetric property, we can say that S12 is S21, S23 is S32, S31 is S4113, S32 is S23, S34 is S43, S41 is S14. And also the diagonal elements S11, S22, S33, S44 is 0. So we know that there is no coupling between port 1 to 3. So S13 and S31 is equal to 0. And also there is no coupling between port 2 and 4. So we can write S24 and S42 also equal to 0. So by substituting all the values in this scattering matrix, we get the scattering matrix of a directional coupler S as 0, S12, 0, S14, S12, 0, S23, 0, 0, S23, 0, S34, S14, 0, S34 and 0. So now we are applying unitary property of S matrix. We can write S12 squared plus S14 squared is equal to 1. Because according to unitary property, if we multiplied S and its complex conjugate, we get unitary matrix. So by multiplying these two, we get three equations. One is by multiplying row 1 and column 1, we get modulus of S12 squared plus modulus of S14 squared is equal to 1, and by multiplying R2 C2 we get S12 squared plus S22 squared is equal to 1, and by multiplying R3 C3 modulus of S23 squared plus S34 squared is equal to 1. So finally we can write the S matrix as 0 P 0 JQ P 0 JQ 0 0 JQ 0 P and JQ 0 P 0. So next is the application part. The directional couplers are widely used for power monitoring, source leveling and isolation applications in RF circuits. And in telecommunication circuits, this passive directional coupler is used in multiplexer, demultiplexer, power splitters, and also it is used in optical switches. So now what is a directional coupler and what are the performance parameters of directional couplers? Define isolation, mention the formula to calculate the coupling factor. Thank you.